OSI model is understandably a confusing subject for many people who are either learning something about networking or preparing for certifications. Oftentimes, instead of actually understanding the network flow that OSI model presents to us, people just memorize different layers, go past the exam, and they say goodbye to this information without retaining this information and processing it for future use. To start from the beginning, OSI model is the networking model that breaks down the networking process into 7 distinct parts, with each part playing a key role in delivering the content that we're looking for on the internet. For example, when you're putting a chocolate sweet into your mouth, it is the first step of the digestion process that your body initiates. And from the moment you put this chocolate sweet into your mouth to the moment when you go to the loo and do what you have to do, this chocolate sweet passes many different stages of digestion in our body. And the OSI model is very similar in a way that it breaks down networking into the different 7 layers that make it easier for us to understand. Before OSI model, if my friend would tell me that he or she works in the networking, I would say, oh cool, that's great, you work in the tech. But nowadays, if someone tells me that he or she works in the networking, I would be wondering, so does she work for an internet provider? Does she work with routers, switches, cables, or which are the initial layers of the networking? Or does she work on application layer? Does she work with browsers, HTTP protocol? Does she work with UDP, TCP? There are so many questions and so many different segments where a person can be useful in networking. So today we'll be looking at each layer specifically with an intent to not to memorize, but to understand how these layers interconnect with each other in delivering us, humans, the content that we need from the internet. To start with, the very first layer of the OSI model, by the way, these layer names are usually similar and the layer numbers as well. So if I say layer number 3, it's networking layer. Layer number 5 is session layer. Some people refer to them by name, other people refer to them by number, but it doesn't make any difference. Physical layer is responsible for passing the bit stream. So what each layer is responsible for is underlined with red, right? Bit stream, what it is? Like, remember bits, it's a bunch of zeros and ones that is basically the information in a way that computer would understand. Imagine that you, a European person, pass some text in Latin letters to someone who is Arabic and who speaks Arabic basically. And the person, after the translation of this text, gets this text in Arabic letters. And if you don't speak Arabic, as I don't too, you would basically get a text with waves, like waves, dots, and you'd be like, okay, I realize that this is Arabic, but I don't speak Arabic, I don't understand it, and for you it would be nothing but waves. Whereas for the other person who speaks Arabic, it would be the language, it would be the whole paragraph. And it works in a similar logic here. So zeros and ones, basically the bit stream, is a translation of the information to a language that computers would understand. Because computers understand this language and they can translate it, not to translate it, but utilize it in a way that it needs to be utilized for further layers. So at physical layer, there is a receiving cable and sending cable. And the main equipment that we need is cables. So imagine my computer is connected via Ethernet cable to my router at home. And whenever I initiate the connection, the data passes from the cable that is connected to my computer to the router or to the switch. And this bit stream, data in a form of a bit stream, passes to the switch, right? It's when our computers are connected via Ethernet cables. And the cable is a necessary equipment in this data transmission. You might ask, nowadays we're using Wi-Fi. So obviously many of our computers are not connected via Ethernet cables. So is this layer still relevant? Yes, this layer is still relevant. There are still cables, although you don't see them. Example, although this is not specifically related to this layer, our router is connected via fiber cable or any other type of cable to our internet provider, and that's how we access the internet. Right? So cables are still in use, but we might not be noticing them as much as we did. In the same way, the cable on your work network, when you go to work and you have a PC there, the computers might be connected to switches via Ethernet cables. And cables are also widely used in server rooms. If I connect my computer using a cable to another computer, I don't need a router to communicate because we're on the same network. We are connected. And that's what physical layer helps us to achieve, as the name suggests, on the physical side of it. After physical layer, the bit stream from the sending cable, bit stream goes to the receiving table. Now sending cable sent the information to the receiving cable. This was the bit stream. What happens to this data next? At the data link layer, we work with frames. Frames is similar to bit stream, with only difference is that this is the form of data that we work with at layer 2, at the data link layer. Data link layer, the main equipment required for the data link layer is switches. You can have smarter switches or smarter routers that can be layer 2 switches, and at layer 3 they can be routers. And on the different exams it often mentioned, or whenever you try to buy a router, it's mentioned that at layer 2 it can be a switch. But without going into specifics, the main equipment at this layer is switches. So what happens at the data link layer? Are we connected to the internet at this layer? The answer is no. Data link layer deals with the intra-network communication, where intra stands for the same network and communication. Imagine that I collect a bunch of laptops, or we are like 4 friends and we connected our laptops via cables. And this is the local area network, LAN, that we've created. At this network, we can exchange information between our computers, but it doesn't mean that we can access Google or we can access anything on the internet, which is outer network. And at the data link layer, we need switches. Switch is a box that received the information from one computer. Computer 1 has MAC address. And the computer looks up. So computer 1 is the MAC address and the information should go to the computer with another MAC address. And using the ARP table, address resolution protocol, it finds another computer on the same network and passes this data. On the basic terms, a switch is like an intermediary. It is an intermediary. Imagine that I'm a switch and I receive the information from one laptop saying, I'm laptop 1, hello, can you please send this information to a laptop with MAC address John? Okay, I will. So MAC address John, let me see in the ARP table, which one is it? Okay, John. It's a laptop number 3. Right, I'm passing the information to laptop number 3. This is basic operation as such, if we look at it. However, it's very important because we are working on the same network level. The data link layer is the layer side that allows us to proceed with this communication. We have flow control and we have error control on this layer. So for example, if the file that John is sending is very big and the transmission is not fast enough, switch can adjust the speed of the transmission so that it doesn't overflow the other computer. So there is no overflow. Imagine John is sending this information at 15 megabytes per second. However, Julie can accept this information only at the speed of 8 megabytes per second. So there is a flow control so that Julie's laptop is not overwhelmed. And obviously there is an error control. So if there is a certain frame, data frame has not been passed, we organize the redirection of these frames. So again, let's recap. Physical layer is about bit stream. It's about cables. Data link layer, it's about frames. It's about switches and about MAC addresses. It's about the same network. Imagine we're in our house and computers are connected together, or we are in the same company. We don't need Google. We don't need outside internet. We are fine. We are okay on our own local area network. However, there is only so much time that you can be okay with it. And at some point, you need the internet. You need to access the outer world. And this is when the network layer comes into place. Remember, network is when we can access the outer world. Otherwise, we wouldn't need network. And remember it by the name of this layer, which is intuitive. It's network layer. And that's when we go to the outer world. That's when we can access Facebook, Google, and other similar websites. Network layer works with packets of data. It's not bitstream, it's not frames, it's packets. And the main equipment piece that you need to remember about this layer is routers. Routers are smarter switches because routers is our gateway to the internet. So imagine switches is our indoor doors. A door of bedroom, a door of bathroom, the doors that we can use to walk in the house. But router is our entrance door that we can use to go out, right? So routers are usually provided to us by our internet providers, and they are the way for us to access the internet. No router, mostly no internet at the house. Network layer is responsible for inter-network communication, meaning that the communication with the outer world, and the protocols that it relies on are usually IP protocol, ICMP protocol, or IPsec suite. IP, many people already know about it. We will talk about it in one of the next videos. ICMP protocol is the layer 3 protocol mostly used to do health checks on the devices. So if you have been preparing for CompTIA, you might be familiar with a command called ping. We ping the device, for example, we ping 1, 2, 3, 4, certain IP. We can ping Google also, anything. The packet protocol that ping uses is ICMP. It's simply the protocol that is trying to understand if the device is on or not. We're trying to understand if device is up and operational. Some companies block ICMPs, in which case the ping will not work due to DDoS restrictions. However, this is still the protocol of this third network layer. Imagine we reach the internet, right? We know how to reach it. We have the router, but what happens next? We've got the router. What's next? Next, we've got a transport layer. At layer number 4, which is the transport layer, we're interested in passing the data from our router through the transport device to the recipient that needs to receive this data. So for example, we're leaving our house through the entrance door, which is a router in this specific example. And we need the means of transport to go from point A, which is my house, to point B. Our transport can be our legs. We can walk there. We can use a car, we can use a public transport, whatever. But we need means of transport for that. And this is what is done on transport layer. Transport layer works with segments. So whereas network layer passes the data in packets, the data is rearranged in segments on the transport layer. So the keyword here is segments. And the transport layer relies on TCP or UDP protocol in order to transport the data. So TCP protocol opens a three-way handshake. So the session includes the three-way handshake, meaning that I send the data and I say, I sent it. Hello, I sent it. And then when the data is received, the person, the party on the other side says, I received the data. And then I say again, the third handshake. Okay, I know that you received the data. I acknowledge it. We will look into more detail of TCP and UDP in another video. But TCP is a guaranteed means of sending the information where we have the three-way handshake. Whereas UDP is not guaranteed. It's a lightweight protocol where the segments just flow, and if one of the segments is lost, it drops. We're not looking for it. We don't care. And this is the means of communication, means of transport of information that we use for the calls. So if I say, hello, my name, Jamila, and then I continue my speech, I live there, and etc. But the is that I lost in my name is Jamila, we're not looking for it. We've lost it. The packets have been dropped. And we're not looking for them because it's UDP. However, on transport layer, we do the flow control, meaning that we don't congest the network and we adjust the speed. So if the data is coming with a high speed, but receiver can only receive it in slower speed, we readjust the data and slowly pass it. And at the same time, if we're getting the data very slowly and the receiver is waiting for the data, we still readjust the speeds or reshuffle the speeds to make sure that there is an average speed between the sender and receiver. We control the flow. And error control make sure that the data that has not been transmitted is retransmitted. I'm not talking about single packets that we've just discussed for UDP. I'm talking about the bigger chunks of data, bigger number of segments. So for example, if the whole speech hasn't been transmitted, we retransmit it. So we check the data for error control, and ultimately we ask the question, is the data complete? Is the data that we're trying to transport complete? Oftentimes, especially when you're preparing for the exam, the flow control and error control is only mentioned at this layer, a transport layer, because here it's done in inter-network communication, when the network goes into the outer world through the router. It's true that we do it in intra-network on layer 2. We have the flow control and error control, but it's released normally when we do the more detailed review. As now, we discussed that there is flow control and error control for layer 2, and for inter-network communication there is a flow control and network error control on layer 4. Once the data passed the network layer, we establish the means of transport, and the session for the transport has been initiated. In order to initiate the session, we need the checkpoint. You can understand the session as sort of itinerary. So when you left your house through the router, you have means of transport, you have your car, but it still means that you have to go somewhere. You're in the car, and why you're there if you have nowhere to go? So when you're in the car, you have to have an itinerary. You have to have an idea where you want to drive from point A to point B. And this is what session layer helps us with. It established the session between the point A and the point B. And within this session, or as a tunnel, if you will, you can start sending the data. The keyword for session is checkpoints. We are using checkpoints when we send the data. So imagine that we send the data in 5 megabit segments. Right? And the total amount of data we need to send size is 100 megabit. It means that we're sending the data in 20 segments, 100 divided by 5. And after sending 52 megabits, we notice that the connection dropped. Then when the session is reopened, where do we start sending the data again? Well, we have checkpoints in the session of communication, so we resume from 52 megabytes. We don't have to start all over again, thanks to session layer. Otherwise, we would have to. So session layer is responsible for resuming the session at the point where we left off. It's very similar to when you're watching a Netflix movie. You watched only 25 minutes, then you stopped. And when you open the movie again, you don't expect to watch 25 minutes again. You want to watch from the moment where you left off last time. Otherwise, Netflix wouldn't be so popular. If it would be so dumb that it would bring you at the beginning of the movie each time you open it. And this is similar to when you go from point A to point B and you stop at the petrol station to fill up somewhere in between. The Google Maps route shouldn't show you your route from point A. You resume where you left off. It shows you the route from petrol station to point B, where you're ultimately headed to. After the session layer, we need to present the data. We need to present the data into a human-readable format. You might ask, what do you mean under present? Do we not receive it in the human-readable format from the session layer? Well, we do receive the content, that's true. However, this content can be compressed because we usually, in the transport layer and during the session layer, we compress the data. Original data, for example, was 200 megabytes. We usually compress it to 100 megabytes. So we have less data to pass, and obviously the network is less congested. And it's best practice to encrypt the data using SSL or handshake or other protocols. So the data that we receive, first, mostly encrypted. Second, it's compressed. What do we need to do? At the presentation layer, before we present it to an end user, we have to decrypt the data and we have to decompress the data. So presentation equals processing, equals preparation. At this layer, you prepare the data for the ultimate user. Once we've prepared the data, we either decompressed it or compressed it, or we encrypted or decrypted it. We are now ready to present the data to the user, right? And this is what happens at the application layer. Application layer, the keyword for this layer is the content. So you're in your browser And when you see the application, when you see the website, you go to booking.com and you see the website where you can put the destination where you're going, the dates, number of people, and etc. etc. And that's when you see the human readable format of this application. You see the content that you're looking for. Normally, normal mortals, ordinary people who are not into tech, they don't care about these 6 layers. They're like, why do we care? These layers are taken care of by internet provider, by a person in the family who knows better about tech. At the company, IT department takes care of this. They only care of the 7th layer, the application, the human readable content that they're actually looking for. So application is synonymous to content. The key protocols of the application layer are HTTP, SMTP. Obviously, if we are mentioning HTTP, we can also mention HTTPS, the secure version of HTTP, via SMTP. Remember, SMTP is mail-related protocol, right? So we see our emails in a human readable format when we open Outlook. We open the application that shows us the emails. So that you don't think in a narrow way that application layer only shows us the website. No, it shows us the websites, the applications, emails, anything that is in the human readable format that we can understand and can be presented to us. Now, when we have reviewed these 7 layers, let's do the reverse traversion. Because oftentimes we can actually be faced with a scenario where the data goes upside down from the bottom to the top. And let's review this specific traversion because it's very, very common. Imagine you're the end user, you're in front of the computer and you're trying to access your Facebook account. You put your username and you put your password on Facebook and you click on login. Or whatever, you're sending the information to the web server, to Facebook's web server. So the application is in human readable format, right? The content, and you send it. Now at the presentation layer, we need to prepare the data. You remember presentation, preparation. We need to prepare the data for the next layers of transmission. And here, since the data is decompressed and decrypted, we need to encrypt it so that in the session and transport layers, the data is encrypted. Otherwise, it can be visible. Someone else can eavesdrop on our network and see what's going on. We encrypt the data, we compress it so the data is slower and it can pass in a smaller size. We prepare it at the presentation layer. At the session layer, we establish the session of communication and we pass the data. We pass the data using the transport layer within a session. At the transport layer, in segments, we pass this data using TCP or UDP. In this specific scenario, it's TCP. When we're sending our credentials, it's usually TCP to make sure that the data reaches the recipient. And we make sure we use flow control and error control so that we don't lose these credentials, we don't lose these segments while transporting them. After we've transported it, at the network layer, now in the form of packets, the data takes most optimal route to reach our router. It's internetworking. It's internet, basically. It's the internet. Our router end user and Facebook's web server. And in the middle is the internet. And our packet takes the most optimal route to reach the Facebook's web server. So when I say most optimal route, it means that it takes the fastest route. So for example, to fly from London to New York, you fly through Atlantic Ocean. You don't fly back through Europe, Russia, and through the back of it, and then through another side of the earth, actually, because there is a faster way through Atlantic Ocean. You know what I mean? So that the route takes the most optimal way. At the network layer, we reach the router of the Facebook's web server. Once we reach the router of Facebook's web server, we are at the data link layer. We pass the router and now we're at the switches. We are in the Facebook's internal network. At the internal network, the switch decides on the web server that the data needs to go to. And we don't need internet for that. Our switches do the flow control and error control in intra-network communication. So switches between themselves within the Facebook's web server, among the web servers define which web server accepts credentials. And then this goes to the needed web server. In order to reach the web server, Facebook uses cables. The switches using the Ethernet cables are connected together. They're connected to web servers, and using the cable, the bit stream goes from switch to the web server using the cable. You might now say, but many companies use cloud. Does it not mean that there are no cables? Well, the cloud providers use cables because cloud providers still have the web servers. Web servers need to be hosted hosted somewhere, and if it has been outsourced, it doesn't mean that they don't exist anymore. They do exist, but it's been done by cloud providers. That was the reverse traversal of the OSI layer. The most common confusion about the OSI layer, OSI layers overall, is that the data always in transit at each of these layers. But this is not true. So it's true that the data is in transit in a bit stream from cable to cable. It's in transit at a data link layer through a cable to a switch, right? It's in transit in networking layer from a switch to a router, or if it's a smart router, it then doesn't need a switch. In transport layer, it's again in transit. At the session layer, session and transport layer can work on top of each other. So transport layer, it's the means of transport, and session, it's sort of itineraries that we have, the tunnels that we have through which the data should pass during the transport layer. So there is a smallest overlap, however they have different functions. At the presentation layer, data is not in transit. The data is being prepared. The content is being prepared for the application layer. And application layer is the layer at which the data is presented in human readable format. So actually, session, presentation and application are usually not about transfer as such, as about in the session layer, if the data has reached the recipient, right, or we resume the session, if the data has been prepared, and at application layer, if the data has reached it. OSI model is a very logical model of understanding different layers of network, because networking is a very complicated term. And when I say internet, what is internet? You remember in this series on Netflix called IT Crowd, I guess, the lady, she was afraid that the internet is a box and she's gonna break the internet. Well, it's not gonna happen, because internet realistically is a vague definition. And OSI layers help us to break down and understand the networking process, how it works and how the network goes from the cable, from the machine on my table to Google's web server, to Facebook's web server, and how we receive this information back. And it happens in milliseconds, we don't even notice. However, the data does this traversion in no time. And that's how humanity evolved in technical terms. If you have something to add about OSI layers, please leave it in the comments down below. If there are more technical topics that you would like me to cover, again, suggest them in the topics in the comments down below. Don't forget to subscribe to my channel. My channel is a small channel, so the more subscribers I have, the more motivated I am to create more videos. Don't forget to follow me on Instagram, and see you later. Bye!